Is the screen visible? Can you see the slides? Okay. Where are the rest of the guys? So let us start now. Uh, in our expert system, uh, in our last lecture, we have started up with uh, the system features, right? The ES system features, and after that, I'm just trying to sum it up that in which way we will be moving. We have got the expert system features to be seen today, the rest part. Then uh, we do have the knowledge acquisition. This is what we'll be seeing today. And so we do have the system features that we'll be seeing. A part of it has been seen yesterday. And then we do have finally the knowledge base and the export system shells. So the export system shells part I'll be taking care in the next lecture, that means tomorrow. So let us begin with this part, that means our export system features. So yesterday we have gone through this goal driven, that means backward chaining is one of the system features of export systems, coping with uncertainty, right? So this is one of the features. So better going through coping with uncertainty, we have got a dedicated part on this. Then comes the forward chaining, right? And the data representation, also one of the features, the way in which the things are represented. We'll be talking in detail about this, the user interface and the explanations, right? So about this, I was asking you yesterday that do you need a dedicated separate lecture for this or not? You haven't responded. We'll be going through this part exclusively, right? So this is here also, and also in the part of data representation, sorry, in the knowledge base in section number 4 of this chapter, we'll be requiring this. So for the time being, one of the features, that means the goal driven feature, I am not saying at present. I'll be doing it after a few more minutes, right? So we'll be seeing this, even though I do have a dedicated lecture on YouTube for this. Now we are coming to uncertainty, right? So in any expert system module where there is an expert and there is a knowledge encoding person or a knowledge encoding engineer, and then a systems engineer who take care of that particular knowledge in the 3 tiers of the architecture of the expert system, right? Now, what is this uncertainty part? Do you think all the information that is extracted or the information that has been rendered by the expert is always in the perfect condition? The answer is a simple no, right? So, knowledge in most of the conditions is imperfect, and it is having a lot of uncertainty. Because why can this thing, why does this thing happens? Because this knowledge is tacit knowledge, right? This knowledge is tacit knowledge. That means this is within oneself. This is based on the experience of that particular expert. Now, To work in a real world, the expert systems must be able to deal with the uncertainty. There are some ways of dealing with uncertainty. The simplest way of dealing with uncertainty is to append or to attach a numeric value to every single piece of information that we are gathering. By doing so, what we do is we can remember the missing links in those pieces of information if they are properly quantized, right? If they are properly quantized. So, inclusion of numeric values in the segment or in the chain of values that we are acquiring. That means in the process of knowledge acquisition, the information that we are acquiring, if we are putting up small pieces of numeric values for, you can say, like making them more filtered, or making them more proper, or making them more oriented, then this uncertainty part can be taken care of to a greater extent, right? Now again, I have the goal-driven one. Now this one is the data-driven one. There will be an exclusive talk on this very soon. Let us cover up certain more part, because see, I have got this one, I have got this one, and I have got this one. I'll be taking care of three lecture materials today. So let me finish up this part first, and I'll be moving to another part. So data representation. Now, in case of data representation, now you do have the slide in front of you. What are the things that we do? Generally, in case of data representation, first we need to have the data, right? That means we must have that particular data to be represented. For having that data to be represented, I must first acquire that particular data. That means I must have the knowledge acquisition to be done first. And from whom we are going to acquire the knowledge? We are going to acquire the knowledge from the expert. And from the expert, that particular knowledge is encoded back to the computer, right? Now, knowledge representation, after we have got the expert, and we have got the encoding person who can extract the knowledge, that means who can acquire the knowledge and can transfer it back to the knowledge base or to the system, then there is one more thing that is left. There are two more things that are left. The first thing is the way of representation. If I'm talking, yes, I've skipped this part now, I'll be talking about it. If I'm talking about the way of representation, then they may be in the form of if-then rules, or semantic networks, or the frames. We have gone through all these three things one by one. We have already gone through it, right? So this is the data representation, or in fact not representation, the orientation part, right? Now I have acquired the things out here. I have represented the things out here. There is one more thing that is to be taken care of. That is about the faithfulness of the representation, that how much data is faithful, that is how much data is accurate, or in fact can be applied honestly to make out decisions, right? So there must not be any losses while we are doing any kind of knowledge acquisitions, or there should not be any kind of tampering with the data while we are acquiring the knowledge. So yes, and another thing is, while putting up data representation, no single representation system can be generically applied to all sorts of expert system shells, right? That means if I have taken up semantic network, then it is not mandatory that in all the expert systems I'll be using the semantic networks for data representation. I can even have the frames, I can even have the simple rule base for the data representation in any expert system, right? Now the next feature, remember these are all the features, right? Data representation was also featured, the backward chaining, the forward chaining, the uncertainty, they were all features, and we are carrying on with the features itself. Now we do have the user interface. As I've already said you, that you do have a knowledge base, you do have a working memory, you do have an inference engine, and then you do have a user interface, UI. Now, I don't have to say much about UI and all these things. You people are having much better ideas about user interface designing nowadays. But there are certain core requirements that are to be addressed while we are talking about the user interface. The core requirements that are to be addressed are that as better as possible, the user experience, the better the user experience will be, the better will be the the better will be the rating of that particular ES or that export system, right? Now, some of the primitive expectations for an user interface is that they must have a scrolling dialog interface. They must have a scrolling dialog interface. They must have pop-up menus. Then some of the better interface windows, right? And they can have certain amount of graphics also to put up a better feature or a better user experience. So user interface is also one of the very important features of the export system that is to be taken care of, right? uh, Let me tell you, nowadays most of the things they go by the UGC guidelines and regulations, and you people are quite aware of it. You can go through the MHRD sites for their information, and maybe by the beginning of this fourth phase of lockdown, at any point of time, they may ask for how the students and the faculty members are responding to this kind of teaching phenomena. So to justify that students were there, we need to have the attendance. So there are hardly 37 people out here right now. So it's up to you to decide that what you will be doing, right? You must have, let me see what the people who are present. Where are the rest? Okay, sure. User interface is over. Now comes explanations. Straight away, I'll say you what explanations and for what the explanations are to be given. In any export system module, explanations means like whatever decision that particular ES module has taken, it must have justifiable amount of, I mean, it must have contents that can justify its decision, or its whatever things it has suggested to that particular user, it must have proper explanations for that, right? So it must have the ability to explain themselves that why and how they are coming to a particular conclusion over a period of time. Now, given the system knows which rules were used, why and which rules were used, the system must have the ability to answer those things during the inference process. As I have already said, the knowledge base, we have the knowledge base, we have the working memory, and we have the inference engine. The inference engine is basically the export system shell, right? It is basically the export system shell where the majority of the decisions are taken, right? Majority of decisions are taken. So for every step that you are taking or the system is taking, they must have the ability to provide explanations for them. To give you certain amount of idea, like recently, uh, there are a lot of, you can go through, I mean, those of you who are working for the chatbots and the user interface kind of projects, like, developing interactive devices or interactive modules. Let's say Elisa is the, it's pretty old, but still the version of Elisa is available in your over the internet. If you're interacting with it, for every kind of answer it provides, there is a kind of explanation that can be asked from that particular system, that why and how that particular system has came to that kind of conclusion, right? So by looking at the explanations, the knowledge engineer can see how the system is behaving and how the rules and data are interacting. It is a very, very valuable diagnostic tool during development also, right? Now comes the most important part of the development of an ES module or an export system module. It is the knowledge acquisition part. What is this knowledge acquisition? Knowledge acquisition, in a very, very layman's term, is acquiring knowledge or collecting knowledge, right? So knowledge acquisition includes elicitation, collection analysis, modeling, and validation of the knowledge. Now we need to know what are the basic issues, because the issues, now within the knowledge acquisition, we do have the issues of knowledge acquisition. This is what you need to remember. Then the techniques of knowledge acquisition that are adopted to acquire the knowledge, and Then we do have, then finally we do have the knowledge base will be going there. Now, uh, let us just come back and talk about the issues. Out of them, issues in knowledge acquisition is one of the most important things. Now, while we are going for a knowledge acquisition, what are the issues that we are going to encounter? The first and the foremost thing, the most important requirement of any export system is the availability of a expert, right? Is the availability of the expert. Now, uh, since I'm developing an export system, it means what? I am somehow replicating. I am replicating to a certain extent what the expert would have done in tackling a particular type of problem, right? So while doing so, while I'm extracting the knowledge from that particular expert, I need to understand that all that knowledge is in the head of the expert, right? And the expert has got a vast amount of knowledge. Now, the moment we talk about the vastness of the knowledge, that means the diversity of the knowledge also we are talking about, and the segment of the knowledge that that is most important to us will be only dealing with that segment. We have already known that this kind of systems, that means the export system, they are highly specific. That means we can develop export system for a very specialized kind of job, maybe for medical domain, and that too in the medical domain also, that may be for the medicines. What should be the recommended medicine for a particular kind of disease, or for a diagnostic tool. That means on the basis of the symptoms that are generated in a particular patient, you can make a prediction for that particular disease, right? So knowledge is in the head of the expert. This is the one of the first issues, and we have to somehow encode, we have to extract and encode it. Now, the experts have a vast amount of knowledge. This is also one of the issues which has to be dealt with very carefully. Now comes the expert have a lot of tacit knowledge. This is the most important thing. Tacit knowledge means they have, that knowledge is not exclusively a bookish knowledge. All the ifs and then statements, I mean the rules that that particular individual adopts, they are they are very much acquired over a large period of time on the basis of the tacit knowledge that they have gained by their particular experience, right? So that tacit knowledge is embedded. We know about tacit knowledge and rest different types of knowledge, right? Wait. Now, since it is a tacit knowledge, so uh, so they themselves don't know that which information is to be extracted or which information is to be shared with that particular that particular knowledge encoding engineer. So the tacit knowledge is somewhat very hard and impossible to be described, impossible kind of, I'm not saying they're exactly impossible, they're kind of it. So, to understand that particular knowledge, there should be a smooth process of handling those kind of issues. Next is, experts are very busy and valuable people. So, if a particular group of scientists they are developing an expert system, they should also know that the person from whom they are performing the knowledge acquisition task, on whom they are performing the knowledge acquisition task, they are very valuable and busy people, and they must find out better and better ways for extracting knowledge in a much more easier fashion from them. Now, uh, it may even happen that the knowledge that we exactly need for particular kind of export system cannot be achieved from only one expert, right? We can have multiple experts from whom we can extract our required knowledge for development of that export system. So more than one expert more than one expert may also be needed, right? Now there is one thing we call it as the shelf life. So there is a wonderful, I guess, as far as I do remember, there's a Moore's law that every 5 or 6 years you need to totally renovate your knowledge, even if you are a doctor or an engineer from a very premier institution, but you need to always add on knowledge, because if you cannot enhance the shelf life of that knowledge, it goes on depleting. Like whatever I know today may not be the reality in the next 5 or 7 years. So it is expected that if you're not acquiring new knowledge for almost 5 to 7 or 10 years, you have lost the self life of what you've acquired almost 10 years back. So this thing is applicable for the self life of the knowledge that is there in our expert system. So these are some of the explanations. I hope it will make you understand the issues related to the expert system in a much more better way. Let us move forward now. Wait, there are people in the lobby. Now, there are a few techniques for knowledge acquisition. Right? There are a few techniques for knowledge acquisition. So we'll be listing out those techniques. There are certain techniques for knowledge acquisition. Let us pick one of them. Each one of them gradually, and let's go through them. The first one is the protocol generation techniques. Right? This is for what? Now, this is the technique for knowledge acquisition. The first one is the protocol generation technique. What is this protocol generation technique? Now, whenever you are putting up an interview or you are taking an interview or you are interacting with a particular expert for knowledge acquisition, there are ways by which you can have that acquisition or you can have that knowledge, right? That knowledge initially can be in the form of unstructured, semi-structured, or in the structured form. And their reporting and observational techniques that are adopted in these kind of processes. But the most important part is out here. That means you need to have, you can get the information either in structured, semi-structured, or in structured format. So these kind of distinctions in the knowledge that you will be acquiring, they come under the techniques of protocol generation techniques. That means under which head you are acquiring that particular knowledge from that expert. Right? Now comes protocol analysis techniques. What is this protocol analysis techniques? Now sometimes we become very, very generic and we generally take up whatever is coming as an information towards us. To the knowledge encoding engineer. Now what happens is that then that person gets a hell lot of text heavy information. Text heavy information means they get the transcripts of the interviews or text based, exclusively text based information, and obviously that information is totally unstructured, right? So protocol analysis techniques are to be applied under those cases to identify the basic knowledge objects within that particular protocol, right? Such as what are your goals and what decisions you need to take and what are the relationships and the attributes that you're going to take care of. These are the things that you will be doing under the head of protocol analysis techniques, right? Then comes the hierarchy generation techniques. In case of hierarchy generation techniques, you have to remember only one word. That means uh, they generally adopt, in case of hierarchy generation techniques for knowledge acquisition features, you have to understand that they adopt laddering, right? They adopt laddering, Laddering, laddering. Generally, ladders are of the forms like, generally, under these head, the knowledge that is acquired, they are done in the basis of on the basis of the concept ladder or attribute ladder or in the form of composition ladders, right? So I'll just hold on for a few seconds out here in case of a hierarchy generation techniques, and we'll go for another piece of information. So here we come up with what is a concept ladder, right? In a concept ladder, it shows generally we do have the subclasses of information. For example, all the relationships in a ladder are in the relationship format, like a car is a vehicle, right? A concept ladder is more commonly known as a taxonomy based, right? They're basically taxonomy. You can just see an example for this. Right? There's a plant type, and within that plant type, you are having two different plant types, right? You're having these two different plant types, and these further plant types have they have further types. So there are sub classifications that goes on in case of our concept ladder. Remember, these are the things that are not there in our generic slides or our common slides, so you can just go through it. I'll be sharing all this data with you also. Right? Now comes the composition ladder. In case of composition ladder, what happens? Now this is the way our knowledge object is composed in its constituent parts, right? Now it has a has part and a part of relationship. It is better to see here. Composition ladder is generally useful way of understanding complex entities such as machines, organization, and documents. So you can better see it here. The forebrain has got, now here these are not types of brain, they are the part of the brain that we talked about: the forebrain, the midbrain, and the hindbrain, right, the backside of the brain. Now we do have further subparts within the forebrain, and then we have further subparts within the midbrain. So this is the kind of ladder that we do create in case of composition ladder. That means one part is composed of what further subparts within them, and that particular subpart has got further subparts within them, right? Has further subparts within them. There is another thing called as the decision ladder. Decision ladder shows the alternative course of action for a particular decision, right? Like it can be better understood from this example. There's a car fuel, right? Now this fuel can be unleaded petrol, it can be diesel, or it can be a battery. These are the three different types of car fuels. Now it depends on your necessity, or on the feasibility of the situation, that what kind of fuel or what kind of propelling component you require for your car. Now it depends on the car make and rest all things. So if I'm taking up unleaded fuel, then again the decision has to be made on the basis of their commonly used, their good performance, and have a low fuel economy. Again, in case of diesel, we do have the common, they're very common, inexpensive, and good fuel economy, and poor performance and noisy engines are there. In case of battery, it is a clean, quiet engine, poor performance is there, longer charge time, and limited journey length. So these are for you to make decision. These kind of ladders helps you to make decision on the long run while you're taking up these ladders. So then comes the attribute ladder. In case of attribute ladder, what happens is an attribute ladder shows the attributes and the values. All the adjective values relevant to a particular attribute are shown as subnodes. Let us see out here. We do have the attributes and values here. Tastiness, on the basis of tastiness. Cost, we do have the fizziness, and serving temperature. These are all the attributes for a class of food in which it must be served. Just a moment. Now again, under tastiness, it is tasty, very tasty, or not tasty. You can have these kind of things. So this is how we do have the process ladder also. So in our main part, or in our main slides out here, we have only talked about that hierarchy generation techniques. They are only based on the various ladder structure, right? Now comes another now comes another heading under the techniques of knowledge acquisition. What is that next technique? The next technique is matrix based techniques. It involves construction and filling in of a 2D matrix, that means grid or a table, now indicating such things as may be, for example, between concepts and properties, attributes and values, or between problems and solutions, or anything of your choice, right? Am I audible? And can you see the slides properly? Because there was a message that came up that the network connection is poor. Okay. How many people are there in the lobby? Acha, I'll stop for 2 minutes here, and I'll be asking you that you can unmute your, you don't have to raise up hands, you can just unmute your mic, and you can tell me that where are the rest of the students. I mean, obviously you don't know, But क्या हो जाता है ये कुछ लोग आप लोग definitely people are in touch with yours. So I'm not concerned about the rest, but since I'm regularly putting up the effort, so I expect all of you to listen to this, or else I'm just putting up the recordings of these also on YouTube. Still, why you people are not there? कहाँ चले जाते? Do you know that tomorrow, maybe from today evening or tomorrow afternoon, Afan is a cyclone that is coming up on the eastern India. So we may have poor connections tomorrow and day after tomorrow, maybe up until Thursday. So I'm not so sure. And then we do have a webinar, GVT webinar. I hope you might have gone through that. We are conducting it on the 20th and 21st, right? So that's the reason why we have taken up the lecture of Sunday, that means yesterday, so that things can be adjusted, right? You want to share something? You want to ask something? You want to ask something? Any one of you? Rajat Tripathi, are you there? Rajat, matlab Rajat has kept the phone aside and he is sleeping, or he is watching TV, or he is doing something else. Ah, Rajat is there. No, Rajat is there. Rajat is there. Then what about this? Rohini Verma, are you there? Rohini Verma, are you there? Arey wow, I'm feeling so good. Then SP Tiwari ji, are you there? Tiwari sahab, are you there? Oh, okay, you raised the hand. So nice. अच्छा अच्छा, देख लिया तिवारी जी, देख लिया. You can put down your hand. Then roll number 221, are you there? Roll number 221, are you there? 221, are you there? Roll number 221, are you there? Okay, roll number 221 is not there. Roll number 221 is sleeping. No, 221. Sir who? अच्छा आप हो, good. Good, good, good. Sure, fine. Let us start up again from here. It's just a kind of ना ना, why are you sorry for late replying? अरे ऐसे समय में सॉरी वॉरी नहीं बोलते यार, बाहर में इतना प्रॉब्लम है, why to say sorry about? कुछ नहीं, सब सही है, बस थोड़ा सा रह लो, थोड़ा सा सुन लो. Okay. So in case of matrix based techniques, Pulkit Yadav left the meeting. Why Pulkit Yadav left the meeting? Call Pulkit Yadav. Okay, now metrics-based techniques. In case of metrics-based techniques, as we have already seen, they are like filling up of the two-dimensional grid and table. हाँ सर सुन रहा हूँ, ठीक है ठीक है ठीक है, good. Now, in case of metrics-based techniques, what happens? I have to give you a kind of an example. Like, let's say you do have a piece of information. You do have uh, you do have I mean, some of my students, almost 2 3 years back, they have worked on it. I do have a chunk of information. Let's say I do have a paragraph, and in this case, in case of this expert system, I do have an expert from whom I have somehow taken up through speech to text converters. I have kept a good amount, a hefty amount of text heavy information. That particular text heavy information is related to a particular specific topic which I know, right? Like I'm talking about some defense systems with a defense expert to make out an export system that can give ideas on what kind of purchases we are supposed to make for defense systems. And from that particular army person who's an expert in that particular domain of arms and ammunitions, if I'm asking him a question and he's answering all those things one after the other, and I've collected the whole of the information as a big hefty piece of paragraph. Now the question comes up that how am I going to acquire this knowledge or extract information from this? One of the simplest way is to adopt NoSQL databases on this to extract the information. But who said that every delimiter that comes up in this particular piece of information will not be carrying any set of relevant or usable piece of knowledge? What I mean is, for every full stop that is there, I can acquire a good amount of information from that particular sentence. Now, let's say that particular expert has said that there are three types of tanks. The tank A is of its name is this, and then tank B type, and tank C type. They are having cost of this, and we can have a modification over tank A, B, and C, and we can create a tank C, right? क्या ये सर रुक जाओ ये सर मैं देखने दो क्या ये सर रे ऋत्विक खत्री व्हाट हैपेंड किस बात का यस चलो कोई नहीं हाँ तो in case of matrix based techniques what we do is we pick up one line each one set of information each and then we extract the relevant content from them removing the stop words and we create a grid. That means in fact in a much more lucid term we create a table out of it and from that table we can apply the normal course of data extraction from them because then we can get the whole of the information in a structured part, right, in a structured form. Now comes sorting techniques. What are these sorting techniques? Now they're used for capturing the way people compare and order concepts, right? It may reveal the knowledge about the classes and the properties and the priorities. So whatever knowledge I have gained, I need to have the sorting techniques that I'll be adopting over them to segregate the information, right? Now, next one is limited information and constrained processing task. Now, techniques that either limit the time and or the information available to the expert while performing that particular task. Now, for everyone, why we generally do it? Like, if I am approaching an expert and I'm talking with that person, it may happen that he would like to give me a set of information which I don't require or I don't need. Under those situations, what am I going to do? Now, I can limit the flow of the information from him or her, right? Flow of information, how am I going to limit it? I cannot say that you just stop, I don't want to take up this kind of information. Rather, what I can do is I can put up a set of questionnaires that I feel is required. I feel is required to be answered. So, under those cases, we pick up those particular questions, and by picking those particular questions, we can limit that particular individual to answer only those questions which are of value to us, that means value to our export system that we are modeling. Now, there are diagram-based techniques also that are there. What are these diagram-based techniques? Now, they include generation and use of concept maps and transition networks, event diagrams. We can also take the information in the form of diagrams, right? So these diagrams speaks a lot. That's why it is better to jot down the information sometimes, not in all occasions, in the form of diagram. That means diagrammatic representation of the knowledge acquisition is also one of the techniques. Now comes the knowledge base. So will not be in case of knowledge base. We're talking about the knowledge base. In knowledge base, what we do have is how we are going to use the knowledge that we have acquired, right? They talk about the three common methods of knowledge representation as we have gone through. They talk about the transferring knowledge, that means the transferring techniques for knowledge, that means human to computer, to create that particular knowledge base. They are basically the heart of the expert system is based on the knowledge base module, right? And these things are there listed earlier. Fine. So uh, the knowledge base creations, the knowledge base types can be if then rules type, that means condition action rules or situation conclusion rules. In this way, we can put up rules for acquiring the knowledge. If there is a condition this, then what action to be taken, or if the situation is this, what kind of conclusion we are going to make. We can have the if then rule type of knowledge base, or now we can have the semantic networks, on which I'll not be talking about because we had exclusive lectures on them, right? We can have semantic networks also for our knowledge based representation. Okay, but there's a small example out here, like this is a semantic network for a Nissan car, right? It is, it belongs, that means it is within the category of a car. There's another one, that means Honda Civic, also it comes under the category of the car, and they both are under the higher subclass, higher higher category space, the higher category class of vehicle. They also have values associated with them. That means the vehicle has wheels, the car has engine, they have the battery. We have gone through all these kind of things. Now, for exclusively for Nissan, we do have the power steering, right? So this is a basic semantic net representation of cars and its qualities. The next one is the frames. We have gone through everything about frames. The frame representation you'll see better is that I stopped with the frame-based representation here. And no, I'll carry on with this frame-based representation, and tomorrow I'll be talking about our backward searches. This part tomorrow I'll be talking about, right? Better I should finish this one first. So I do have a frame for a car, right? I do have a frame for a car. Now the frame car carries and is a representation of inheritance slot. That means it has got, the vehicle has got a value. Then the engine has got an attribute slot. They have got particular values like the vehicle and its values, that how many numbers are there, the cardinality of it. Then the cylinder is again another attribute slot. That means within the frame car, I do have multiple slots, starting the inheritance slot, the attribute slot, for the engine, the attribute slot for the cylinders, and its particular values like it can be a 4-cylinder, it can be 6-cylinder, it can be a 8-cylinder, right? Now the number of the doors. When I do have an attribute slot on the doors, I can have 2 door, 5 door, 4 door kind of car, right? Now, likewise, I do have another the second example of it is also there. Web Jan coming now. Now, next one is the working memory. I'll be finishing up with the working memory and export system shells tomorrow. Okay. So, we are having. Can we finish up the lecture here today? What do you say? Can we finish it up here? So, Suresh, you can do one thing. You can take up the attendance now. Okay, taken. Then all of you can gradually leave the meeting, and we are again going to meet tomorrow at the same time. That means 4:40.